Example 5, we're going to prove a property. So prove that 3 is a factor of 4n minus 1 for all integers n is greater than or equal to 1. So first we're going to do 1. When n equals 1, the formula is valid. Because 4 to the 1 minus 1 equals 3, right? We're trying to prove that it's a factor. So 3 is a factor. So part 2, assuming that 3 is a factor of 4k minus 1, we're going to show that 3 is a factor of 4 to the k plus 1 minus 1. Okay, so next. So 4 to the k plus 1 minus 1. So what we're going to do here is we have 4 to the k plus 1. What I'm going to do is I'm going to subtract 4k and add 4k and then minus 1. So notice that in here, the negative 4k plus 4k, that is 0. So I'm really not changing anything. I'm just, putting something in here. Now, the reason why I'm going to do that is because I'm going to factor by grouping. So I'm going to take this here. Now, I want to factor out a 4k. So remember 4k plus 1. So another way to look at 4k plus 1, that's 4k plus 1 is 4k times 4. So when I take out a 4k from here, then this is just going to be a 4, and negative 4k, that's a minus 1. Then I'm left with this 4k minus 1 here. Now simplifying this is 4 to the k times 3 plus this 4k minus 1. So notice here that 3 is a factor. So now let's write this out. Because 3 is a factor of 4k times 3, and 3 is also a factor of, we said it here, it's a factor. We said that 3 is a factor of 4k minus 1, right? We assume that. It follows that 3 is a factor of 4n minus 1 for all integers of n is greater than or equal to 1. Okay, so really you're drawing this big line here. So first we plugged in n equals 1. And then we said that, oh yes, we do get a factor of 3 here. So that's true. Now we're going to assume that 3 is a factor of 4k minus 1. We're saying that. We're going to show that 3 is a factor of 4 to the k plus 1 minus 1, right? And we did that work here, and look, we did prove it. 4k plus 1, we added and subtracted here, so we can regroup. And look, we have a 4 minus 1, which is 3. That is true. So then what we're saying is this part right here, we already said that that is true. That is a 3, and of course 3 is a factor here, so it's just drawing the line all the way back from the beginning. So try out this example here. Prove that 2 is a factor of 3 to the n plus 1 for all integers n is greater than or equal to 1. There is no typo here. You should see that 2 is a factor of whatever number you get after you plug in 1. All right. So when you plug it in, when n equals 1, the formula is valid because 3 to the 1 plus 1 is 4. And really, we can rewrite that as 2 squared. So remember, 2 is a factor. So you can see that 2 is a factor of this value here, 3n plus 1. So we assume that 2 is a factor of 3k plus 1. Show that 2 is a factor of 3 to the k plus 1 plus 1. So 3k plus 1 plus 1, you do the same exact thing you did before. So you're going to subtract 3k, add 3k. So you have 3k times, when you factor out the 3k, you get 3 times 3 minus 1, plus this 3k plus 1 at the end. And you notice 3 minus 1 is 2. So because 2 is a factor of 3k times 2, and 2 is also a factor of this 3k plus 1, then it follows that 2 is a factor of 3n plus 1 for all integers n is greater than or equal to 1.